And then for the next 2 years, 1 point something billion miles, the spacecraft will go around the sun twice and return to the vicinity of Earth, where at that point it will release its sample return capsule with the science gold that we collected back last October. And that spacecraft will then re-enter and land in the Utah desert, where scientists will cheer excitedly about this incredible return.
What will NASA do
with the material? Maybe more. This is really the building blocks of why we're here, why we have oceans, how organic molecules could have become life. We're going to look at that record for the first time with these priceless samples. They're a kind of a gift that keeps on giving for future generations. So our kids' will have these building blocks of how our planet, how our great life presence came to be. So this is an epic moment. Ingenuity is a tribute to the great women and men engineers, at NASA's JPL, to actually go from sitting still on a planet to roving, which we've been doing marvelously with Curiosity and other rovers like Spirit and Opportunity, to now flying. This is the future. We can move in different ways on planets. Flying on Mars, we'll be flying on Titan in about a decade. These are the new mobility techniques that we people use on Earth. Now we're applying them to explore places that we will go, like Mars. This is just more fun than you can imagine.
Our audience, if you can hear that low hum, that is the sound of the helicopter actually flying around Mars. Listen to that. That is really cool. Are your experts learning a whole lot about Mars from this helicopter?
Showed rocks and dust escaping the sampler head. The team believed it collected a sufficient sample and decided to seal the tagsam to preserve the remaining material. The spacecraft made one more flyover of Bennu and saw just how big a mark it left on the asteroid's surface. The tag event sent boulders flying across Nightingale's surface. OSIRIS-REx completed its last flyover of Bennu at around 6 a.m. Eastern on April 7, 2021, and slowly began drifting away from the asteroid. On May 10, 2021, OSIRIS-REx fired its thrusters and began its 2-year cruise back home to Earth. As OSIRIS-REx approaches Earth, it will jettison the sample return capsule that contains pieces from asteroid Bennu. The SRC will then travel through Earth's atmosphere and land under parachutes at the Utah Test and Training Range on September 24, 2023. Once recovered, the capsule will be transported to the curation facility at NASA's Johnson Space Center, where the sample will be removed for distribution to laboratories worldwide, enabling scientists to study the formation of our solar system and Earth as a habitable planet.
In December 2018, after traveling for 2 years, 101 days, and over 1.2 billion miles, NASA's OSIRIS-REx spacecraft arrived at its target, near-Earth asteroid Bennu. OSIRIS-REx is the first mission to explore this primitive remnant from the origins of the solar system, designed to study the asteroid and return a sample to Earth. Bennu is a dark, diminutive world, roughly the height of a skyscraper, and now the smallest body to be orbited by a spacecraft. Prior to arrival, it was known to have low thermal inertia, a characteristic of fine-grained materials like sand. An infrared spectrometer on OSIRIS-REx confirmed this property, leading scientists to expect a predominantly smooth surface. But the first close-up views of Bennu delivered a major surprise. In exquisite detail, the mission's cameras revealed an unrelenting rockscape dominated by boulders. By combining these images from OSIRIS-REx with its laser altimetry data, we can take a tour of Bennu's remarkable terrain. The first stop is Simurgh Saxum. This prominent boulder defines the asteroid's prime meridian and serves as the basis of its coordinate system. In Persian mythology, the Simurgh is a large and benevolent bird and the possessor of all knowledge. Saxum is Latin for stone. To the northeast lies the largest boulder on Bennu. Measuring over 300 feet in length, rock Saxum is a colossus longer than a football field. It is also rich in a type of iron oxide called magnetite, which was used by mariners as an early form of magnetic compass. In Arab folklore, the rock is an enormous bird of prey that can clasp elephants in its talons, as well as stranded sailors like the hero Sinbad. Continuing northeast over the equatorial ridge, we arrive at Gargoyle Saxum. This striking boulder is among the darkest on Bennu, though it clutches a much brighter rock that is about the size of a person. In medieval legend, gargoyles are dragon-like, winged monsters that can breathe fire and that guard cathedrals from evil spirits. Our next destination takes us far to the east. At the northern end of a small crater lies Ocypete Saxum, a comparatively bright boulder measuring about 33 feet in diameter. Ocypete Saxum is located near one of 3 sites where Bennu ejected small particles into space in early 2019, displaying its dynamic and evolving nature. In Greek mythology, Ocypete is one of the 3 harpies, the half-maiden, half-bird personifications of storm winds, who would carry evildoers away from the earth. In the creation stories of ancient Egypt, the universe began as a formless, endless expanse of water. From this primordial sea arose the primordial mound, Benben. It was upon this rock that the god Atum settled in the form of the Bennu bird and sent forth the call that shaped creation. The story of Benben harkens to the mounds of fertile silt that once emerged from the receding floodwaters of the Nile, and it provides a fitting namesake for the tallest boulder on Bennu. Protruding by over 70 feet, Benben Saxum is so tall that it was first detected from Earth. Now, we can appreciate this monumental feature in detail using data from OSIRIS-REx. The final stop on our tour is a cluster of exceptionally bright boulders scattered across the southern hemisphere. They bear the spectral fingerprint of pyroxene, a mineral found in igneous rock that is unlikely to have formed on Bennu. These boulders most likely originated on the large asteroid Vesta and were delivered to Bennu's parent body through meteoroid impacts. Although it is small in size, asteroid Bennu has proved to be a fascinating world, abundant in geographic features that have defied our expectations. Thanks to OSIRIS-REx, we can now explore Bennu to uncover its composition, its evolution, and its ancient memories from the origins of the solar system.
As we started to approach Bennu from a distance and it started to fill up the camera field of view, it looked exactly like we thought it would, with a few boulders sticking out. But as we got closer, we expected to see a very sandy surface with maybe a few boulders here and there. And what we saw is very little sand. And we saw these mountains, we saw boulders, we saw rocks, and we saw very few areas that had this sandy surface that we were expecting and what we had designed to.
We have never done this before. We're actually going to collect a sample and bring it back down to Earth for further examination by scientists.
In order to achieve that objective, the OSIRIS-REx spacecraft has been navigating around Bennu for about the last 2 years, studying it in great detail, and also overcoming a number of challenges that Bennu has presented. We were looking for locations on Bennu that were 50 meters in diameter, relatively flat, and covered with fine-grained material. And by fine-grained material, I mean stuff that's the size of a dime or smaller. We realized that there were no sites on Bennu that even came close to meeting this criteria. Everywhere we looked was too small and covered with boulders. So we actually had to fly a number of additional closed passes over the asteroid and rethink our entire plan for grabbing the sample. After the additional observations of Bennu, we had to down-select to 4 sites, and then go back and survey those sites even further to select the final primary sample site.
My first impression of Nightingale is that's the last place I wanted to go. But as we started looking at other sites, we saw that one, this is probably one of the most sampleable sites, and two, we were overperforming in our navigation capability and our ability to contact. Natural feature tracking works a lot like the human mind in that we pick up landmarks along the way. As we descend, we look at features on the ground. We program the computer to recognize certain features. It takes a picture, says this feature is not where I expected it to be, it's a little bit off to the side, updates its position based on where it's pointed and where that feature shows up in the camera position.
The tag event is our touch and go event, which is where we'll actually be retrieving the sample from asteroid Bennu. We start with a series of maneuvers, one of them being the checkpoint burn, which is where we'll actually check our position and velocity in relation to the sample site.
And then the match point burn, about 10 minutes later, will zero out our horizontal velocity relative to the surface. And then about 10 minutes after that, we make contact with the tag SAM, fire the gas bottle, and then back away.
And we hope to get at least 60 grams of sample, and then we'll be able to store that and bring it back down to Earth.
But there are several things that could go wrong, and we also have to be prepared that we won't be successful on our first try at Nightingale.
We don't only get one shot at tag, we actually have 3 nitrogen bottles on board the spacecraft, so we can potentially do 3 tag attempts if needed. We go through several what-if scenarios, and this is how we actually prepare for a lot of our contingencies.
So we've had to look all around the surface and identify the rocks and boulders that if the spacecraft were to tip over up to 25 degrees, it could come into contact and be damaged.
We had to develop a hazard map, which we program into the computer and says, if you're getting too close to those hazards, we'll do a wave off, we'll back away from the asteroid, we'll come back and do this another day.
Everything might work perfectly. We come down, we touch the surface just where we want to, we fire the gas bottle, but the area we contact is covered in large rocks. Those rocks would prevent any fine-grained material from being stirred up and captured in the tag SAM head. Another similar scenario is if the tag SAM were to touch on the edge of a boulder and become tipped up. In that case, when the gas bottle fires, much of that gas escapes out the side, not churning up the material that we want to capture. The day of tag is going to be really exciting, but the excitement for our team doesn't end there.
We have to verify that we have a proper sample.
First, we're going to image the tag SAM head by sticking it in front of one of the cameras. Then we're going to do a maneuver called the sample mass measurement, in which we stick out the arm and we spin the spacecraft in order for us to decide if we've collected enough mass to be able to stow the sample and return home, or if we have to try again.
This is the culmination of a lot of work. It's probably one of the most exciting missions that I've worked on.
It is really exciting to know that we're finally going to be able to touch the surface of the asteroid and collect the sample to return back to Earth.
After its discovery in 1999, our first hints of what asteroid Bennu looked like came from the Arecibo Observatory. Then, as the OSIRIS-REx spacecraft made its way to Bennu, the asteroid grew in detail from a few tiny pixels to a surprisingly rugged world.